Hey guys, in this video we're going to cover what a RESTful API is and then some of the main characteristics of the Express framework in Node.js. After the slides, we are going to create a simple REST API using Express. REST is an architectural style for APIs. REST stands for Representational State Transfer. It is based in the HTTP protocol, and basically in REST we talk about resources and operations, where the resources are defined by using URIs and the operations are defined by using HTTP verbs or methods. We're going to see that in detail in a minute. REST APIs typically exchange data in JSON format, but you can use other types of formats such as XML. REST provides a client-server architecture. By separating the user interface from the data storage, it improves the portability of the user interface across multiple platforms such as web, mobile, and others. And it also improves scalability by simplifying the server components. REST is stateless. Each request to the server must contain all the information necessary to handle the request and cannot take advantage of any stored context on the server. Session state is kept entirely on the client. REST is cacheable. The data within a response to a request should be implicitly or explicitly labeled as cacheable or non-cacheable. If a response is cacheable, then a client cache is given the right to reuse that response data for any equivalent requests. REST provides a uniform interface, and it is defined by some constraints. One of them is hypermedia as the engine of the application state. I'm going to add a link in the description below to the Richardson's maturity model, where he explains the different levels of REST. Most of the time we work on level 2 of REST following this model, and that basically means that we use HTTP verbs, but level 3 includes hypermedia as the engine of the application state. And it's not that common to find it implemented, but it's one of the main principles of RESTful APIs, and there are a lot of people that is not aware of that. As I mentioned before, REST is basically defined by resources and actions. The resources are defined by using a URI. In this case, we have tasks, and in order to execute operations in a RESTful API to manipulate those tasks, we have these 4 HTTP verbs or methods. 5 actually, if we consider the patch HTTP method. We use the post verb to create a new resource, in this case a new task. We use the get HTTP method to read a task. We use put to update the entire task, or patch to update a subset of its attributes. And we use delete to remove a task. So if we want to create a task, we specify the post HTTP verb and the task URI as the resource. And we also pass a JSON payload in the body of the HTTP post request. If we want to read the data from a specific task, we use the get HTTP verb and the task URI as the resource, including the task ID. If we want to update the data of a specific task, we use the put HTTP verb and the task URI as the resource, including the task identifier. Or we can also use the patch HTTP method to update a subset of the attributes. For example, if we just want to change the description field of the task, we can use patch for that specific change. If we want to remove a task, we use the delete HTTP verb and the task URI as the resource, including the task ID. Another important concept is the ability of a RESTful API to inform the result of the execution of an action. The HTTP codes allow to provide that information, and these are the most common HTTP response code. If we create a new task successfully by using post, we get a 201. If we execute this post operation using a wrong URL, we get a 404. And if the resource is already created, we get a 409. When we use get, when we read an existing task, if we find the task, we get a 200. But if we don't find the task or the ID is not valid, we get a 404. If we use put or patch to update an existing task, if the operation was executed successfully, we get a 200. If the operation was executed successfully, but there is no response from the server, we get a 204. If the task is not found, we get a 404. And if the put or patch method are not allowed, we get a 405. And when we use the delete HTTP verb and the operation is executed successfully, we get a 200. And if the task is not found on the server, we get a 404. And if the delete method is not allowed by the server, we get a 405. Okay, let's review what Express is and how we can use it to create a RESTful API. Express is a minimal and flexible web framework for Node.js. It allows us to easily create RESTful APIs. Express provides the routing to handle post, get, put, patch, and delete operations. Express also provides middleware functions to include error handling, authentication, login, etc. in our backend API. Remember to subscribe to the channel, and let's move on to the demo where we are going to create a simple RESTful API using Express in Node.js. Okay, let's get started. Let's create a new directory. Let's call it tasks API. Let's go to that directory and let's init the project. And to do that, we need to do npm init with this option. So we get the package that JSON created. And now we are going to install some dependencies. First, we are going to install Express, of course, npm I express. Then we're going to install another dependency called joy. We are going to use joy to validate the data. We're going to create a schema. We are going to validate the data that we received by using this library. So again, npm I joy. And finally, we're going to install Nodemon. Nodemon allows us to have a hot reload. So when we make any changes in our code, it will automatically apply those changes. So we don't have to restart the server every time that we make a change. So npm I -g, because I'm going to install this globally, Nodemon. Okay, now let's move on to Visual Studio Code, and I'm going to open that project folder that is on desktop, projects, tasks API. This is our project, it's empty. So we are going to create first an index.js, and we are going to start creating our API. First, we're going to import Express. And in order to do that, we are going to use this sentence, the required sentence. And we use Express to access the Express framework. Okay, and we're going to create another constant here that's going to be our app. And using this, we instantiate the Express framework. What we're going to do is we're going to implement all the RESTful methods. We're going to implement get, post, put, patch, and delete. So what we are going to do is we're going to create first an array locally, and we're going to use that as our quote-unquote database. So const tasks equals, and here we create an array, and we create a bunch of tasks. So ID 1, name, task 1, and we add another Boolean attribute that is completed. Completed, false. Okay, I'm going to copy and paste this. So we have at least 3 tasks in our storage, in our array. Okay, I'm going to remove this. So we have task 2. Let's make the IDs, the identifiers, unique. Task 2. plus 3. Okay. So let's get started with the get HTTP method or verb. We use app.get and we pass the path or the resource. And here we receive two parameters on this function, this callback function, or the function that is going to handle the requests. We have two parameters here. We have the request and the response. We get the data from the client in the request, and we send the data to the client using the response. So basically, we are going to do some pretty basic tests here. Response.send, and here we send something like welcome to the tasks API. Okay, and before running this, I need to start the server actually. So I'm going to create a constant. This is going to be the port in our server. So the API is going to be listening in this port. Process.env. Using this, we access the environment variables, and we're going to use port. So typically when you go to production or another environment different from the local environment, we use this port variable or these environment variables, in particular in this case the port variable, to specify the port of the application. We're going to use the port 3000 to develop locally. And what we need to do here is app.listen, and here we specify the port, and we specify the callback, and in this case we are going to just log that we are listening on a specific port, console.log, and we can use backticks here. And here we are going to log the port where we are listening on port, and here we use template literals, and here we include the port constant, port. Let's save this and let's try this out. Nodemon index.js. Okay, let's go now to Postman, and if we go to localhost /API/tasks, we should get the message that we are sending here. Welcome to the tasks API. Okay, now let's move on and let's return here, instead of this message, let's return these tasks. So we are going to return all the tasks that we have in our quote-unquote database. So we just replace this string, this message, by tasks. So if we test again, we should get an array with all the tasks. So let's make some changes here just to validate that everything is working and that the changes are reflected. So I'm going to save this. I'm going to send the request again, and yes, the completed value changed from true to false. Okay, and now let's add a new get method, and in this case we're going to get by ID. So I'm going to copy this, and we're going to include the identifier of the task to get the data of that specific task. So in order to access that parameter, We're going to name it task ID, and we get that from the requests object, request.params.id. Here we can control that if we don't receive a param, we return a 404. I'm going to add that validation here. And here we can do, if no task ID, return response. We set the status code like this, status 404. And then we send a message where we say the identifier is not valid, or the provided identifier is not valid. Okay, so I'm going to remove this. Let's keep this in one line. And what I'm going to do is, first I'm going to find the task with the ID provided in the request within this array. So I'm going to use the find method, const task. This is going to be the result of the search, tasks.find, and here I'm going to use an arrow function where, given a task that is within the array, I'm gonna return the task which ID is equals to the one that I received in the request as a parameter. So this task ID that I received is a string, so I need to parse that value as an integer. So I'm going to use the parse in global function task ID. Okay, and I'm going to return the task. And also, if I'm going to copy this, and if I don't find any task, I'm going to also return a 404. The task does not exist. Or the task with the provided ID does not exist. That's better. Okay, so let's try this. Let's go back to Postman and let's execute a get operation. And we're going to pass 1, and we get the task. If we pass 2, we get the task again. And if we pass 2, 3, 4, 4, 4, any random value that we know that it doesn't exist, we're going to get a 404, and we get the message that the task with the provided ID does not exist. Okay. And this case doesn't apply because if we don't pass any ID, it's going to be handled by this one. So this, I'm going to remove this because we don't need it. Okay, let's move on to the post method to create new tasks. In order to do that, I need to include the JSON support, and because I need to send data in the body, including the different attributes of the task object. So I need to include the JSON supporting Express using this sentence, app use express.json. And now, doing this, I am able to send in a request, in a post request, or in a put, or in a patch request, I'm able to send the JSON structure. So app.post, I'm going to put the resource here. That's going to be /API/ tasks, and I'm going to add the arrow function. And as always, we receive a request and a response. And what I'm going to do now is I'm going to add some validation because we're going to receive this JSON payload. So we need to validate that the data is actually valid. So I'm going to use Choi for that. So I'm going to create a new folder. Let's call this utils. And I'm going to add a new file here. And I'm going to call this task schema. Within this file, what I'm going to do is I'm going to create the task schema, and I'm going to add a function to validate that the input is actually valid for the schema that we define. So I'm going to import Choi here, const Choi equals require Choi, and now I'm going to define the schema. Task schema equals, and here I'm going to define two attributes. I'm going to define the name of the task, that is going to be a string, show that string, the minimum size of the string, let's say 3, and this field is going to be required. And then the other field is the completed attribute, that is going to be a boolean. And now I'm going to add a function that is going to validate that when we receive a task, it's valid for this schema definition that we declared here. So function validate task. Here we're going to receive a task, and we are going to use show.validate, and this function receives the object, in this case the task, and the schema, that is task schema in this case, the one that we just defined here. So I can make this simpler. I can use an arrow function actually. I can remove this, and I can assign this to a variable, validate task. And what I need to do is I need to export this function so I can use it in my index.js. Okay, so I'm going to import that here. I'm going to declare a variable, name utils, const utils equals require, and this is slash utils slash task schema.js. And here I'm going to use that validate task function. This validate method is going to return an error or success. So what I'm going to do is I'm going to use the structuring to get the error from that validation. So I'm going to do something like this. Const error equals utils that validate task, and I'm going to pass the body. The body is going to be the JSON that we receive in the request. Okay. And if there is an error, I'm going to return in the response the status 400, and I'm going to send a message that says the name should be at least 3 chars long, because that's the only field. If we go back to the schema definition, that's the only thing that is required, and it has a minimum of 3 characters. Okay, so let's say that we receive the task as we expect. So we are going to create the task using the request data. So I'm going to create an object literal here, and I'm going to generate the ID by using the length of the array plus 1, just to keep it simple. We can also use UID for this. And the name is going to be request.params.name. Sorry, request.body.name actually. And the completed attribute is going to be request.body.completed. And what I'm going to do here is I'm going to push this new task into the array. That push. And I'm going to send the task in the response. Response.send, and we send the task. Okay, let's try this now. So let's go to Postman and let's create a post here. So let's add a task for completed false. And we're going to execute a post request on this URI, that is actually this one. And let's say that we are going to pass a task name with 2 characters. So we should get a 400 error. Yes, we get a bad request, that is a 400 HTTP code, and we get the message, the name should be at least 3 chars long. So we're going to complete the name using more than 3 characters. And we're going to submit this. And now we get this task created. And if we go back to the list of tasks by executing a get verb on this resource, we're going to see that we have 4 tasks. The original 3 tasks that we created, and the last one that we just created by using the post HTTP request. Okay, let's move on to the put method. So in this case, we're going to update a task. So we're going to need to receive the identifier of the task and a JSON that includes the attributes that we want to change in the task. So app.put, here we specify the resource, /API, /tasks, /:ID. Here we define the arrow function with the request and the response. And first we're going to get the task ID. I'm going to copy that line from here. We're going to find the task within the array. I'm going to copy that as well. So now we have the task that we want to update. And we also need to handle the situation where we don't find any task with the ID that we received. So we are going to return a 404 and the same message that we send when we don't find the task in the get operation. That's the same case. So maybe we can refactor this and move this code that is repeated to some external function. Let's keep it as it is for now. So, and now what we need to do is we need to validate the request, and we are going to use the same code that we use in the post operation, where we receive the JSON as part of the request. Okay, so, and here again, we need to handle if we get any errors, we're going to send this message to the user or to the client of our API actually. Okay, and if everything goes fine, we assign the task that name. This is actually the task that is in our quote-unquote database, that is the array here. And this is going to be request.body.name, and the task that completed is going to be equals to request.body.completed. And we are going to send the task, the updated task actually, as the response. Send, and we send the task. Okay, let's try this. Let's execute the put method, and let's change the first task. So let's check what we have. So the first task, the ID is 1, the name is task 1, and completed false. So we're going to add some changes here so we can see that we are actually changing something there. So task 1 change, and let's switch the value from false to true. Let's execute this operation. And request is not defined. So, here, that's the problem. Let's go back. Let's run this again. Okay, and now we get a 200, and we get the task that we updated. So let's check that the task was actually updated. Yes, we see that the name changed and the completed value changed from false to true. The same if we get the task from here. Okay, let's move on now to the patch method. That is going to be pretty similar to the put method. But remember that the difference is that when we use patch, we just change a subset of the attributes. So let's, in this case, we are going to change either the completed attribute, the name of the task, or both. So we're going to need the task ID again. We're going to need to find the task that we need to modify. We are going to handle the case where the task is not found. We're going to need to validate the request again. So this is going to be pretty similar. This is going to need some refactoring because we are copy pasting a lot of code. So we're going to keep it as it is just to move forward. So if we get any errors, we return a 400 with this message. So if we don't get an error, we're going to assign the task name with the one that we received as part of the request. And if we need to check if we received the completed attribute, that is actually optional, as we can see here, is optional, so it's not required. So we need to check that the value is provided in the request. So in that case, we update that value in the task. Completed. In this case, we are going to assign the new value to the task. Request that body that completed. And we're going to return in the response the updated task. Okay, let's try this out. I need to actually change this, replace it by patch, and now we can test. Okay, let's go to the patch method. So let's say that I'm going to change just the name of task 1. So first let's test that we pass, I don't know, an empty string. So we're gonna get a 400 error and a message. So task number 1. Let's use that. And as we can see, the task has been updated. And if we get the task, we're going to see that we have the new name assigned to that task. Okay, let's move on to the last method of our RESTful API. And this is going to be the delete. So here we're going to use app.delete. We're going to define the resource API/tasks. And here again, we're going to need the identifier to know which task we want to remove from our database, in this case from this array. And as usual, we receive a request and a response in our arrow function. And here we get the identifier as part of the params. And we need to find, again, we need to find the task by using that identifier. And if we don't find any task, we need to send this 404 to the client. And now what we're going to do is we're going to use the splice method to remove the element, but first we need to find what is the index of that element. So I'm going to create this constant index that is going to be equals to tasks.index of, and we pass the element to get the index of that element within the array. And now we are going to do tasks.splice, and we pass the index and 1 because we want to remove that specific element. And now we send back the element that we just removed. That is the task. Okay, let's try this out. Let's go back to Postman. Let's execute the delete of the first task. And if we try to get that task, we're going to get a 404 here because we removed that element. And the same, we're going to see that this collection is going to have just 2 items, the task 2 and the task 3, because we removed the first element. Okay, so going back a little bit, we implemented a get operation to get all the tasks, actually all the elements within this array. Then we implemented the get by ID to get the data from a specific task. We created a post operation so we can create a new task. We added the put operation to update a task. We also created the patch operation to change a subset of attributes of the task. And finally, we created the delete method to remove a specific task.